Hi everyone, welcome to Stranded on Mars, a math game focusing on quadratic function. Topics included in this game are graphing quadratic function, types of graph such as linear, quadratic, exponential, and square root functions, factoring, quadratic formula, imaginary number, and solving radical equations. Here's the background story for the game. It's year 2032. After years of training, you are selected as one of the astronauts on the manned mission to Mars. Although you watch many movies on astronauts getting left behind on Mars, you did not take them seriously. After all, they were fiction. Yet after a horrible storm, you found yourself stranded on Mars. Luckily, your crewmates found out and are on their way back to Mars to save you. Until their arrival, there are only two options: give up or solve the problems to stay alive till rescue comes. You have 45 minutes to create your survival plan and organize data to send an update to NASA and your crew. The whole world is waiting to hear from you. These are the items needed for this game. First, set your lock to the following combinations. 3-digit lock is 577, 4-digit lock is 0178, directional lock is right, down, left, left, down. The letter lock is alone. The game is revolved around the astronaut's journal. There are 4 puzzles for 4 locks. Handouts for this game are the journal entries, which are 9 pages, map legend, Mars facts, test flights, Mars and price sheet. The printouts are the journal entries, the Mars map, and price sheet. These are needed for each group. Only one copy is needed for map legend, Mars facts, and test flights handouts. With invisible ink pen, write the hidden messages below each factoring problem on journal entry 6. Below the first problem, write both. There is nothing for the second problem. Write less than symbol for both third and fourth problems. For the last problem, write either. It is optional but recommended that all printed handouts are laminated so they can be reused for another class. To set up the box, place the reflection cards and the prize handout inside the big lock box. Lock the box with a 3-digit lock, 4-digit lock, directional lock, and 5-letter lock. Post the map, legend, Mars facts, and test flights handouts on the wall. They don't have to be in the same area. Each group should have a large lockbox with locks on them, 9 pages of journal, Mars map handout, and UV flashlight. That's it for the setup of the game. The rest of the video will explain how to solve the game. Journal entry 1 and 2 provide more background to the story. To open the 4-digit lock, students have to solve the food problem. There are 6 steps for this puzzle, and journal entries 3, 4, and 5 are needed. The overall goal of this problem is to calculate how much food is available and how much food needs to be generated in order to last till rescue day. The first step of the problem is to calculate calories from available food supplies. Multiply the calorie per serving by number of servings for each food, then add up the numbers to get 211,000 calories. Step 2 is to calculate how long it takes to harvest potatoes. Journal entry 4 presents the problem as every 4 n sols. Students will have to solve the radical equation on the bottom of the page. Once they find out n is equal to 7, they multiply 7 by 4 to get 28. Potatoes can be harvested every 28 sols. Here's a side note: potato harvest time is only information for students on whether growing potatoes is a viable option for generating calories. For example, if they're not stranded on Mars for more than 28 days, then there is no point in growing potatoes, because they won't be there to harvest the potatoes. This part is not needed in the calculation for the 4-digit lock. Step 3 is to calculate how many calories is in each potato. Journal entry 4 says that 1 potato is x calories. Solve the other radical equation on the bottom of the page to get x is equal to 163. So each potato has 163 calories. Step 4 is to calculate the minimum daily calorie requirement. Journal entry 5 says the minimum daily requirement is 60 t calories. Again, use the radical equation to solve for t. T is equal to 25, then multiply it by 60 to arrive at the answer that 1500 calories are needed each day. Step 5 is to calculate the time until rescue. Journal entry 5 says it takes 70 B souls till rescue arrives. Solve the radical equation for B equal to 8, then multiply it by 20. It takes 160 souls till rescue comes. The last step is to utilize all the information calculated to see how many potatoes need to be grown and harvested in order to generate enough calories to stay alive until rescue comes. 1,500 calories is needed per soul, and there are 160 souls, so 240,000 total calories are needed during the time we are on Mars. There are 211,000 calories available from the food supply, so you need to generate 29,000 calories from the potatoes. Each potato gives you 163 calories, so dividing numbers tells you that you need to grow 178 potatoes. Final answer needs to be rounded because you cannot have part of a potato planted. Students might think this is the answer for the 3-digit lock until they solve the few problem, which also gives them a 3-digit number. Use journal entry 6 for the 5-letter lock. There are 2 steps to solve this puzzle. The first step is to solve the 5 factoring problems. Afterwards, use the UV flashlight to get the hidden message below each problem. For the first problem, the hidden message is both, so you have to use both answers, x equals negative 1.5 and 1. Match the numbers to the chart. Negative 1.5 gives you the letter L. For problem 1, you will get A for 1 and L for negative 1.5. There is nothing for problem 2. For problem 3, you will get N for 2. Problem 4 gives you O for negative 4. The last problem uses either of the imaginary numbers and points to the first row of the chart, which says imaginary number is E. Combine these letters, spell out alone. Nothing needs to be solved for journal entry 7. This is just extra information. To open the directional lock, students will have to use journal entry 8, Mars map and Mars map legend. As shown, there are 5 soil samples collected, demonstrated by the colors. This provides a hint that there are 5 directions for the lock and to use the Mars map. Each pair of colored dots gives one type of graph. The red dots make a quadratic function graph, giving the direction right. Gray dots make exponential graph, which is down. Blue dots and purple dots are linear graphs, so 2 lefts. Green dots make an exponential graph, which is down. Together, the answer is right down, left, left down. To open the 3-digit lock, students will need to use the Mars facts and test flights handouts posted on the wall in their room. Journal entry 9 directs them to the handouts. The goal of the few problem is to calculate the time it takes for the space shuttle to leave Mars. There are 3 steps to this problem. Step 1, students have to identify the height of the atmosphere in Mars using the Mars facts chart, then convert 10.8 kilometers to 35,433.07 feet using a conversion factor at the bottom of the chart. If you'd like to make this a little more challenging, feel free to write the conversion factors with invisible ink pen. Step 2, plot the points to obtain a quadratic function graph, then obtain a quadratic equation from the graph. It is recommended that students use a graphing calculator for this step. On the calculator, press Stat to enter. For editing the list, use the times for list 1 and altitude for list 2. Click Stat again, Calc on the top, and choose the 5th option for quadratic regression to obtain the equation. A link for a video tutorial is available on YouTube. If students have not learned how to plot scatterplot or generate regression line on the calculator, post a step-by-step guide in the room. The link is attached. The last step is to set the equation equal to the height of the Mars atmosphere. Use quadratic formula to solve for t. Although quadratic formula has plus or minus, there is no need for calculate for the subtraction answer because you can't have negative time. Students will arrive at the answer 57.7 seconds. Rounded to open the 3-digit lock. When students open the box, they will find the prize, which is a handout saying that they have escaped. You can congratulate them and make a comment that they won't have to be worried if they are ever stranded on Mars. Start the reflection discussion using the reflection cards in the box. You can find the specific reflection questions on the website.